Okay, so last part of section 2.1 we're going to look at is called angular velocity. So I'll explain to you what angular velocity is, okay, why we can have it, and then basically how we can convert. So this section is going to be about converting one unit basically to another unit. So what angular velocity measures is the speed of something that's spinning. Okay, that's what it is. When do you measure speeds of something spinning? Well, some power tools are rated in like how many revolutions per minute they make. Like if you have a Dremel, it's like a drill kind of, but it spins fast. It's rated usually, I think they go from 5,000 to 30,000 RPM. That's how fast the bit on a Dremel can spin. All right. They don't measure the speed of a tool like that in like miles per hour, because it doesn't make sense to measure that. Miles per hour would be if something was moving in a straight line. Right? This is spinning in a circle. So angular velocity could also be called angular speed. That's the same thing. It measures the speed of something spinning. Now there are technically 3 units that we can use to measure the size of a spin. Right? We could measure revolutions. That measures something spinning. We could use degrees. That also can measure something spinning. And we can use radians. If they don't give you a unit to use, always assume they want radians. I would clarify that on the test though. But in the homework, I know there is a question where they say, find the angular velocity, and they don't say what unit to use radians. Okay. All right, so why do we have angular velocity? Okay, let's take a look at that circle. Okay, it's got 3 dots on it. The middle one that's black, the red one in the middle, and then the outer black dot. Okay, I'm going to spin that circle one time, and I want to see what's going to happen. But first, does anybody remember the formula to find distance? It has distance equals
the square root of x.
Oh, I know what you're thinking of. You're thinking of the distance formula. You're right. Let me clarify my question. It's going to involve speed and time to find distance.
I learned about this a couple weeks ago in physics.
How do you figure out your distance if you know your speed and how long you've been traveling at that speed?
Don't you divide them or something?
You what? You multiply them. Good. If you're driving at 50 miles an hour for 3 hours, you multiply those 2 things together. 50 times 3 means you would have traveled 150 miles. Okay. So now, let's think of it this way. What would R equal? That's your rate of speed.
D over T.
Yeah, take your distance,
See,
divide by your
there's
time.
there somewhere.
Yeah, that's
So
what we use it.
if you take, like, if you traveled 400 miles and it took you 8 hours to do it, 400 divided by 8 gives you an average of 50 miles an hour. Yeah. Okay, so now let's look at this picture. As I spin the disc, I want you to just kind of watch what happens. Okay, each dot is making 1 revolution. Everyone agree with that? They all went around. One of them kind of looked like it stayed in the middle, but it was spinning in place. Out of those 3 dots, just number them 1, 2, 3, did they all travel the same amount? No. Which dot traveled the farthest?
3.
Dot 3 traveled the farthest. It made the biggest revolution. Dot 2, the second biggest, and dot 1 looked like it didn't move at all. So does that mean you'd say the speed of dot 1 is 0? No, it's spinning in place, so it's still moving. But dot 3 definitely traveled the farthest. How much time did it take dot 1, dot 2, and dot 3 to each make 1 revolution? They all made 1 revolution in the same amount of time. So what would that mean then? If dot 3 traveled the farthest in the same amount of time that dot 2 traveled its distance,
It's going faster.
that would mean dot 3 would have to be going faster because it traveled farther than dot 2 in the same amount of time. then that gets confusing. How do you describe the speed of that disk? Do you describe the speed like you were standing right there? Right there? Do you describe it like you were on the edge? Because every dot from the center to the edge is moving at a different linear speed. So that's why when something's spinning, we don't use linear speed. We use angular speed. No matter which dot you look at, we can say each one of those dots made one revolution in, maybe it took me 3 seconds to bring them around. They all have a speed of 1 revolution per 3 seconds. Right? That's why we use angular speed. So angular speed, as I said before, it's always going to be measured in radians per time unit if they don't say otherwise. The only other 2 units you can use, right there, are degrees, if they tell you you can, and revolutions. Okay. Revolutions is very common, like I said, for different power tools, RPMs, like on a meter, tachometer in your car. But we're going to be sticking with radians if they don't give us a unit. So angular speed, radians per, what's the time unit? The time can be any time unit. Seconds, minutes, hours, days, whatever they give you in the book. Now, comparing that to linear speed, there's lots of units we can use to measure linear speed. For the distance part, you can use inches, you can use feet. Feet, you might use that in physics. Miles is pretty common, like in a car, they use that for the distance part, miles. Kilometers is also common in other countries. Centimeters, millimeters, inches, feet, miles, those are all measurements you can use for linear speed. Again, a time unit, that can be any time unit they give you. Hours is common. Okay, so any question on the difference between what kind of unit measures angular speed and what kind of unit measures linear speed? Angular is something revolving. Revolving has to be radians, degrees, or revolutions. Straight line distance, there's lots of units you can use to measure a straight line. And the way that we're going to convert between different units is the same way I taught you how to convert between degrees and radians. We're going to try to cancel out the unit that we don't want. Okay? It's called dimensional analysis. So like if you've got degrees in a fraction and it's in the top and you don't want it, then you put it in the bottom of another fraction. And using dimensional analysis, it's pretty straightforward. As far as conversions, there are some conversions you need to know, okay, that I would not give you on a test. Examples would be how many seconds in a minute, minutes in an hour, hours in a day, days in a year, inches in a foot, how many feet in a yard, feet in a mile. Sometimes people don't know that one.
What is it?
How many feet in a mile?
It's 2,000 something, right?
5,280. Yep.
It's a very awkward number.
Yep. Yeah. It's not like the metric system. So that's the one that sometimes people don't know, but you do. Those are the conversions you need to know. If there's any other conversion that comes up, like how many millimeters in an inch, I don't expect you to know that.
Wait, you said 5,280.
5,280.
And we'll need to know that?
Yeah.
How much? 5,000?
280.
But other conversions I would give you. Okay, like how many millimeters in an inch, you don't need to know that. It's 25.4 if you know that. But you don't need to know that. All right, so we're going to start with a conversion that's not even a speed. Okay, that's 3 days is not speed. 3 days is just time. Okay, that's all it is. And I'm going to convert that to minutes. I think most people would be pretty comfortable doing it, but I'm going to show you kind of an easy one first, and then if you get that one, you'll be able to do all the other ones. It's not a fraction right now, so I'm just going to put a 1 over it to make it a fraction. As I convert days to minutes, I'm going to go 1 unit at a time. What's the next unit down from a day that's smaller?
Hours.
Okay, so we're going to go to hours. So in this step, I'm going to try to make days disappear. So where would days go?
The bottom.
Days would go in the bottom,
1 day is 24 hours.
and hours would go in the top.
Mhm.
So now you've filled where your labels are going to go. Now fill in the numbers. And you can put anything here that's true. I heard 1 day is 24. If you want to do 2 days is 48, well, you could. But I would pick the simplest you can. Okay, so days is gone. Now we want to go from the next unit down from an hour. What's the next unit down from an hour? Minutes. That brings us to the final unit they want. So we're going to make hours cancel out. Where would hours go?
60 hours. 60, never mind.
It's bottom.
Bottom.
Hours in the bottom.
1 hour is 60 minutes.
Minutes would go in the top. And now fill in a fact that you know is true.
1 and 60.
1 hour is 60 minutes. Yeah, any true fact would work. The smallest one is better. Okay. What's the only unit that's left? Minutes. Okay. This time, we don't have any numbers in the denominator, so we don't have to worry about dividing. It's all ones. 3 times 24 times 60. So in 3 days, there's 4,320 minutes. And that's it. That's how you convert days to minutes. Questions on that one? All right. So now, let's try one that's an actual speed. I know that, or velocity. That's a velocity because look at the label. It has a distance and a time part to it. It's feet per second. So what does that mean? 50 feet / second.
50 feet per second.
Right, it means whatever we're looking at is moving 50 feet in 1 second. Okay, what do they want for a length unit in the final answer?
Miles per hour.
Length, just length.
Feet.
Miles.
Miles. Okay, they want miles in the final answer. They're giving us feet. They say to convert 2 miles. So we got to fix that. And what do they want for a time unit?
Hours.
They want hours. What do we have right now? Seconds. We got to fix that. So we're going to fix both of them one at a time. It doesn't matter which one you fix first. Let's
Do feet.
okay. Let's do the feet. So we want feet to disappear. Where would feet go in the next fraction?
Bottom.
Goes in the bottom. What unit would go in the top?
Miles.
Miles. And now we need a fact that connects feet and miles.
1 to 5280.
Yeah. In 1 foot, it's 5,280 miles. Okay. Feet and feet are gone. If we stopped there,
I have a question.
what would be my unit on the final answer?
You said there's 1 foot and 5,000 something.
Oh.
Yeah, I did it the wrong way. One, I think, yeah. Thank you. 1 mile is 5,280 feet. Okay, so if we stop there, what would be our units?
Miles and seconds.
We would have miles per second if they want miles per hour. Okay. So now the next unit we're going to get rid of is seconds. Where would seconds go in that next fraction? Go on the top. And what unit would go in the bottom? Remember, we're working our way towards hours, but there's a unit in between. Minutes. What's the fact I could fill in here?
60 seconds is 1 minute.
Yep, 60 seconds is 1 minute. And now, if you stopped there, you would have a speed in what unit?
Minutes.
Miles a minute.
Miles per minute, yeah. They want miles per hour. Okay. So we need one more.
Minute would go on the top,
Minute go in the top,
an hour on the bottom.
hour on the bottom,
60 minutes for 1 hour.
and the conversion is a 60 to 1. 60 minutes in 1 hour. Okay. What unit are we left with in the top now? Miles. What unit are we left with in the bottom? Hours.
How did you cross out the 60 seconds?
The seconds?
Yeah. Oh, even if it's not next to it, it's fine?
Yeah. Yep. And now we're going to multiply straight across, but this time we do have to divide by something. Okay, so the way I would do it is I would type in 50 times 60 times 60. Okay, get the answer for the top first, and then divide that by what's in the bottom. So it's 34.09. And what's my speed on it? What's my unit?
Miles per hour.
Miles per hour. There are a couple units where you might see a 3-letter abbreviation. That is one of them. If you see MPH, MPH stands for miles per hour. If you see RPMs, right, RPM, that is revolutions per minute. Those are generally the only two that would have a 3-letter abbreviation.
Seconds is the seconds of 3-letter?
Yeah.
Well, that's just a time unit. It's not a velocity unit.
Yeah.
Yeah. So MPH is velocity. RPM is also velocity. One's angular, one's linear. Okay. Is there any question on that? All right. Let's try this one. So the last problem was a linear velocity, and we just changed it to different units that were linear. That is an angular velocity, and we're going to change it to a different angular unit.
Can you go angular to linear?
Yes. That'll be the last thing we do. So this object is spinning 200 radians every second. That's pretty fast, considering there, well, I mean, it depends on what you consider fast, but in one revolution, there's 6.28 radians. So this is doing a lot more than one revolution a second. It's going pretty fast. So let's figure out how many revolutions per minute it's making. Is there any unit that they're giving me to start with that is okay to leave in the final answer? No.
No.
They're both wrong. Well, they're not wrong. They're just not the right unit for the problem. Okay. Which one do we want to fix first? Okay. So we want to get rid of radians, and we want to get revolutions. Even if you don't know the conversion, you should know where radians is going to go.
The bottom.
It's got to go in the bottom. Yep. Now we need the conversion. What's the connection between radians and revolutions?
You say it was like 6.4 or something.
So we want to put the conversion as an exact answer. There is a way to write it exact.
Which is?
Oh, is it 2 pi?
2 pi. Yep. There are
Oh, good.
2 pi radians. We did that on Tuesday. 2 pi radians in 1 revolution. Okay. What do you have at that step in terms of a unit?
Rev per second.
You have revolutions per second. We want per minute. Okay, so now what unit would go in the top of that last fraction?
Second.
Seconds? What unit would go in the bottom?
Minutes.
Seconds? Minutes? Seconds is gone.
1 minute is 60 seconds.
1 minute, 60 seconds. Okay, so let's see how many revolutions per minute this is making. So you got, if you want to type it all in at once, you can. This is how you would do it. 200 times 60. You have to put the numerator in parentheses, and you have to put the denominator in parentheses. That's how you type the whole thing in one step. If you don't type it with parentheses, I'll show you what happens. 200 times 60 divided by 2 pi. That is definitely not the same answer. That is wrong. Okay. The answer is 1,930. Okay. Any question why you need the parentheses?
What are we rounding to?
We're going to go 2. So 1909.86. It's almost a couple thousand revolutions per minute. Any question on that? All right, so the last one I want to do is I want to convert from angular to linear. Right, so what would that really mean? Well, pretend like you had a tire. It was on a machine, and the machine was spinning it. Maybe it's spinning it at like 600 revolutions per minute. Maybe it's a machine that would balance tires. And let's say that that tire fell off the machine and it hit the ground. Okay? What's going to happen if the tire is spinning and it falls off the machine and hits the ground? It's going to keep spinning, and now it's all of a sudden going to go in a straight line. Same idea if you had a rope, right? And you had something on the end of the rope, and you're swinging the rope. If you let the rope go, all of a sudden the speed that was spinning it in a circle, when you let it go, it converts it to a straight line. And it starts going at a certain speed. So that's what converting angular to linear does. It takes the speed of something that was spinning, pretends like it hits the ground, and all of a sudden, how fast would it be rolling? Okay. So I just want to do 2 things. I know that at the highest speed, my Dremel spins at 30,000 RPM. And chuck on it is probably like, we'll call it a 1/2 inch, the whole width of it. So I want to figure out if that bit came off and it started rolling and it didn't lose traction or hit anything, how fast would it be rolling? We'll figure that out after. But let's start with this one. So we've got a wheel that's 18 inches in radius, and the wheel is spinning at 1850 RPMs. What did I say if you see RPMs? What did I say it stands for?
Rotate.
RPM, revolutions per minute.
Revolutions per minute, or rotation, yeah. Revolutions per minute. All right. So let's figure out the linear speed of the wheel at a point right on the edge. Now, I do have to say on the edge of the tire like that. Because if you go back to the disc, every point on the wheel is at a different speed. I want to know right on the edge of the tire, the speed of the wheel. All right, so what's the speed that they are giving me to start the problem off?
1,050 RPM.
Okay, 1,850 what?
RPM.
And how would you write that as a fraction?
RPM for 1.
Put it over what?
18 inches.
How are we going to write that as a fraction? Yep.
Over 1, the rotations on top is 1 below.
Okay, so there's your fraction. 1850 revolutions per 1 minute. Okay, is either unit there the one they want in the final answer? No. Let's fix the time one first. Okay, where would minutes go to fix?
The top.
Yeah, and what would go in the bottom?
Second.
And the conversion between the two.
1 minute is 60 seconds.
1 minute and 60 seconds. Okay, so now we've got revolutions per second. What we want is feet per second. Okay. Is there a piece of information we haven't used yet?
18 inches.
Yeah, so this one we've got to be a little careful. They want feet in the final answer. But how is this wheel being measured? It's being measured in inches. So if we want, we can fix that right now. How many feet is 18 inches? 1.5. Okay, If you divide inches by 12, that's how you can change it to feet. Okay, I would just do that off to the side right now. Any question how we changed inches to feet? Okay. So now, what unit am I trying to get rid of? What is it? I can't hear you.
RPM.
Red.
Revenue.
Just revolutions, yeah. Trying to get rid of revolutions. So where would it go in this fraction?
On the bottom.
Go in the bottom. And what unit do we want to replace it with? Feet. Now we need to fill that in. How many feet in a revolution?
Would be 15.
No.
1.5.
No. Well, maybe. Could be. I guess. How many feet in a revolution?
360 degrees.
Well, that's how many degrees in a revolution.
Yep.
What do we need?
How many feet?
Few of them.
More than one.
Maybe.
Wait, can it change?
Could be. The number of feet in a revolution depends on how big the revolution is. Is it a revolution we're measuring around the sun? It's a very big revolution. A lot of feet in that one. How many feet in this revolution? Not even one. So we have to figure out this conversion. Okay? That conversion is unique to each problem. It's not like me saying how many minutes in an hour, how many seconds in a minute, how many hours in a day. Those conversions stay the same all the time. They never change. But how many feet in a revolution? That's different in every problem. So, think of a revolution, just like that. What's another name for one revolution if you're like tracing that circle?
Circumference.
It's the circumference. So in order to find how many feet in one time around, in one revolution, you need to find the circumference. Okay. Another way to think of it, pretend like that's a loop of string. You're cutting that loop, you're laying it out flat, and you're measuring how long it is. That's the circumference. Okay. What's the formula for the circumference? 2 pi r. Okay. If we go back up, what's the radius of our wheel?
8.
1.5 feet. So the circumference of the wheel is 2 times pi times 1.5. I want to leave that exact. What's 2 pi times 1.5?
3.
Exact. Yeah, 3 pi. That's how many feet there are for this tire to revolve one time. Another way you could think of it, pretend like you had the tire on the ground and you put a marker. Roll the tire on the ground along until that mark is back on the ground again. The amount of distance that the tire rolls is the circumference of the tire. Okay. So there are that many feet in one revolution. All right, let's do that up. So we've got 1850 times 3 times pi. So I did everything in the top first, then I hit enter. Because I did it that way, I don't need to put parentheses. I'm just going to do divide by 60. It's 290 point, we'll call it 290.6 feet per second. Now, most of us probably don't think that is familiar in feet per second. We think in miles per hour. So think how fast that is. We did a problem earlier, and what was it? 50 feet per second was 30, we'll call it 34 miles an hour. This is almost 300 feet per second. It's 290. If it was 300 feet per second, how many times faster would it be than that?
6.
Yeah, it'd be 6 times faster. So if you take that and you multiply it by 6, you're talking about something almost 200 miles an hour. So if that tire was on a machine, it came off, it hit the ground, and it was coming at you at 200 miles an hour, you were probably not getting out of the way. Maybe if you had a couple football fields between you and the machine, maybe. But if the tire was over there and you're here, no.
You're screwed.
Okay, that's 290 feet per second. Any question on that one? Yeah,
I was going to say
sure. Okay, so the last one is purely because I'm interested in knowing this.
Oh. What if we're not?
That's unfortunate.
I don't think we have a choice.
So do people know what a Dremel is? Dremel?
Yeah.
It's like a tool, like a drill, but it spins a lot faster. So if you have a variable speed Dremel, it usually goes between 5,000 and 30,000 RPMs. That's the speeds. So a Dremel bit spins at 30,000 RPMs. It's 30,000 revolutions per minute. Now, it doesn't take the same size, it's a pretty small chuck. You can't really put a big drill bit in it. But the whole thing that spins is probably about, I'd say, a ½ inch wide. So a Dremel bit spins at 30,000 RPM, and we'll say the chuck on it is a ½ inch wide. I want to know how fast that would be spinning if it came off, hit the ground, and started rolling without losing any traction or hitting another object. Okay? And I'd like it in miles per hour because that makes the most sense to me to know how fast something's going. So how fast in miles per hour? Okay. So what's the speed that they give us?
30,000 RPM.
30,000.
We're trying to convert that to miles per hour.
30,000 what?
30,000 RPM.
And what does that mean?
Rotations per minute, so it's revolutions over 1 minute.
Okay. So if we're trying to get miles per hour, let's fix the hours right away. How do you get rid of minutes? Where does it go?
On the top.
It goes on the top.
And then hours on the bottom.
Hours in the bottom. And the connection there.
1 hour is 60 minutes.
1 hour. 1 hour is 60 minutes. Okay, so now we have a speed in revolutions per hour. Now we can't go to miles right away because I didn't measure how wide the tip of the Dremel was in miles. Okay, it's going to be a very small number. But we can go to inches right away. Where would revolutions go so I cancel it out?
Bottom.
Goes in the bottom,
And you write 0.5 inches.
and I can put inches in the top. Okay, how many inches in a revolution? Well, that's the width of the tip of the Dremel, like the bit.
Yes. You don't know.
We don't know that. We're talking about if the bit was on the ground and it rolled one time, how long would it roll for?
So we need to find like the circumference.
We need the circumference of the bit.
Yeah.
So the circumference is 2 pi r. What's the, I didn't specify here, but the chuck the whole thing is 0.5 inches. So that's the diameter. So what's the radius?
0.25.
Right, so we'll say it's a 1/4 inch for the radius. What's 2 times 1/4? Half. That's the circumference of the bit. Okay. 0.5 pi. It's small. It's not a big number. Okay, so that's how many inches in a revolution. Now I want to get that into miles. How do I get rid of inches?
You're gonna put it into, oh yeah, sorry, inches. Wait. Right, you're gonna put inches on the bottom.
Inches on the bottom.
Feet on the top.
Okay, how many inches in a foot?
You get 12.
12 to 1. Now I want to get rid of feet. Where's that going to go?
Feet on the bottom,
Feet on the bottom.
and then 5,280 on the top.
Well, what unit goes on the top first?
Miles, 5,280.
1 mile on top of
Oh, yeah, my bad. Yeah, 1 mile on top, 5,280 on the bottom.
And now what unit are we left with in the top?
mile.
And what unit are we left with in the bottom?
Hour.
Okay, so we're going to multiply that out, and then that'll tell us if the bit came off, didn't hit anything, and it just started rolling right away when it hit the ground, how fast it would be rolling. Okay, because there's a few different conversions, I'm going to use parentheses again. So you're going to do 30,000 times 60 times 0.5 pi, and you don't need times 1 times 1. And we're going to divide by 1, 1, 1, 12, and 5,280. 12 times 50, 280. So that bit would be rolling at about 40, almost 45 miles an hour. That's how fast it would be going. So 44.62. So even though it's spinning at such a high speed, 30,000 revolutions per minute, it really wouldn't be rolling that fast because it's not very big. Right? If you had like a tire on a car spinning at 30,000 RPMs, you'd probably be going thousands of miles an hour. That'd be very fast. All right, so any questions on converting between angular and linear speed? Okay, so the homework tonight, it's 2.1 part 3, so same section as the other two from last night and the night before. 99, 100, 108, and 110. Okay, we've got about 25 minutes, so please use the time to try to get started, especially if you're confused, can't seem to kind of figure out what the question's asking. It's all about angular and linear velocity. I will help you get started with each question.
Do you think there'll be about like 2 tomorrow on the test?
Of these, 1 or 2. Okay, and I'll put the list of test topics on the board right now. Okay. And those are the topics that will be on the test tomorrow, and that covers 1.1 and 2.1.